n tends to infinity, n into 3 raised to n by n into x minus 2 whole raised to n plus n into 3 raised to n plus 1 plus 3 raised to n is equal to, the answer is given 1 by 3 is equal to 1 by 3. Find range of x. So by direct substitution, this become infinity into 3 raised to infinity. That is equal to infinity into infinity. So that is an indeterminate form. The answer is a real number, 1 by 3. So we can write this is equal to limit n tends to infinity, n into 3 raised to n by, take the common factor n into 3 raised to n in the denominator. This is equal to, take n into 3 raised to n in the denominator. N into 3 raised to n into x minus 2 whole raised to n by 3 raised to n plus, here n into 3 raised to n is taken outside, so the remaining term become 3 plus 3 raised to n is taken outside, so this become 1 by n. Okay. Now limit n tends to infinity, 1 by n is equal to 0. So this term become 0. Okay. Now cancel the common term n and n, 3 raised to n and 3 raised to n. So this is equal to limit n tends to infinity, 1 by x minus 2 by 3 whole raised to n plus 3 plus 0 is equal to 1 by 3. So the value of this limit is equal to 1 by 3 when this term is equal to 0. That implies limit n tends to infinity, x minus 2 by 3 whole raised to n is equal to 0. Number minus 1 less than a less than 1, then a raised to infinity is equal to 0. So for this term to be 0, x minus 2 by 3 less than 1 less than minus 1. Multiply 3 to here, cross multiplying by 3. This indicate minus 3 less than x minus 2 less than 3. Or 2 is taking this side and 2 is taking to this side. Minus 1 less than x less than 5. Existence of limit. Limit is said to be exist if left hand limit is equal to right hand limit. That is, limit x tends to a minus f of x is equal to limit x tends to a plus f of x. This is equal to limit, this you can write this is equal to f of a minus is equal to f of a plus, or limit h tends to 0, f of a minus h is equal to limit h tends to 0, f of a plus h. Right. So in where h is a positive number such that h tends to 0. Infinity is a very small quantity. Here what we are doing is we are replacing x by a minus h and evaluating the limit h tends to 0. Here what we are doing is replacing x by a plus h and evaluate the limit such that h tends to 0. Then we say limit is exists for problems of modulus function signum function, greatest integer functions, fractional part functions, defined functions, and function in the form 1 by x, 1 by x cube, 1 by x raised to 5, etc. That is 1 by odd power of x. In general, 1 by x raised to 2n plus 1. Where n is equal to 0, 1, 2, 3, so on. 0, 2, 3. That is 1 by x raised to odd integers. All these cases, we have to take LHL. All these cases, we have to check LHL and RHL. We have to, that is left hand limit and right hand limit, to find the existence of limit. Limit x tends to a 1 by x minus a whole raised to 2n plus 1, where n belongs to integers. Find n belongs to find limit. Here, this function is the form 1 by x power odd integer. So, we have to take left hand limit and right hand limit. If LHL is equal to RHL, then limit exists. Okay. F of a minus, that is equal to limit x tends to a minus f of x. That is equal to limit h tends to 0 f of a minus h. That means replace x by a minus h. A minus h. So this become limit h tends to 0 1 by x become a minus h minus a whole raised to 2n plus 1. This a and a get cancelled. This is equal to limit h tends to 0 1 by minus h whole raised to 2n plus 1. That is minus h all raised to 2n plus 1. That we can write is equal to 1 by this odd power. So minus can be taken outside. Minus 1 into h raised to 2n plus 1. That is equal to limit h tends to 0. 1 by minus 0 raised to 2n plus 1. That is equal to minus infinity is equal to left hand limit. Right hand limit. Right hand limit. That is f of a plus is equal to limit x tends to a plus f of x is equal to limit h tends to 0 f of a plus h. That is replace x by a plus h by a plus h. So this become limit h tends to 0 1 by a plus h, x is replaced by a plus h minus a the whole raised to 2n plus 1, 2n plus 1. That is equal to raised to 2n plus 1. That is this a and a get cancel. Limit h tends to 0 1 by h all raised to 2n plus 1. 0 raised to 2n plus 1. That is equal to 1 by 0 is equal to plus infinity. Here left hand limit is equal to minus infinity and right hand limit is equal to plus infinity. LHL not equal to RHL. Therefore limit does not exist. Limit does not exist. Limit x tends to 0 plus x into e raised to 1 by x divided by 1 plus e raised to 1 by x. Here we need only to find right hand limit. Right. That is x tends to 0 plus. So this become limit h tends to 0 f of a plus h. Here a is equal to 0. So x is equal to 0 plus h or x is equal to h. Therefore replace all x by h. Then apply limit h tends to 0. H tends to 0. So this problem become limit h tends to 0. X is replaced by h. H into e raised to 1 by h divided by 1 plus e raised to 1 by h. Okay. What's the value of e raised to 1 by h? E raised to 1 by h. That is limit h tends to 0, e raised to 1 by h is equal to e raised to 1 by 0, that is equal to e raised to infinity, that is equal to infinity. So, take e raised to 1 by h common from numerator and denominator. So, this is equal to limit h tends to 0, e raised to 1 by h I take common into h divided by e raised to 1 by h into this term become 1 by e raised to 1 by h plus 1 is equal to limit h tends to 0, h divided by 1 by e raised to 1 by h plus 1. H is now substitute h equal to 0. 0 by 1 by the value of e raised to 1 by h is equal to infinity. 1 by infinity plus 1, that is equal to 0 by 1 by infinity is equal to 0 plus 1 is equal to 0 by 1 is equal to 0. If limit x tends to 0, 1 plus a cube plus 8 e raised to 1 by x divided by 1 plus 1 minus b cube into e raised to 1 by x is equal to 2 given. Then find a and b. Okay. Now, what is e raised to 1 by x? E raised to 1 by x. As x tends to 0, this become e raised to 1 by 0 is equal to e raised to infinity. That is equal to e raised, that is equal to infinity. Okay. Now find left hand limit. For that, limit h tends to 0, f of a minus h. Here a is equal to 0, that is equal to limit h tends to 0, f of minus h. Replace all x by minus h and apply limit h tends to 0. So this become limit h tends to 0, 1 plus a cube plus 8 into e raised to minus 1 by h divided by 1 plus 1 minus b cube into e raised to minus 1 by h. Okay. Now, what is e raised to minus 1 by h? E raised to minus 1 by h is equal to 0. That is equal to e raised to minus infinity is equal to 1 by e raised to infinity. E raised to infinity is equal to infinity. So this is equal to 1 by infinity is equal to 0. So this term equal to 0 and this term it is equal to 0. So that is become 1 plus a cube plus 8 into 0 by 1 plus 1 minus b cube into 0. That is equal to 1 plus a cube. Since limit is exist, so we have LHL is equal to RHL is equal to 2. Right. So value of 1 plus a cube is equal to 2. So 1 plus a cube is equal to 2, or a cube is equal to 1. This implies a is equal to 1. Now, right hand limit, that is f of 0 plus, that is equal to limit h tends to 0, f of 0 plus h. Replace all x in the function by h. So the limit become f of 0 plus is equal to limit h tends to 0, 1 plus a cube plus 8 into e raised to 1 by h divided by 1 plus 1 minus b cube into e raised to 1 by h. Okay. So what is e raised to 1 by 0? E raised to 1 by 0 is equal to infinity. So this becomes infinity by infinity form. E raised to 1 by h is equal to infinity. This term is equal to infinity. So infinity by infinity form. So take e raised to 1 by h common from both numerator and denominator. So this is equal to limit h tends to 0. I am taking e raised to 1 by h common. E raised to 1 by h into 1 plus a cube divided by e raised to 1 by h plus 8 divided by 1 e raised to 1 by h into, this term become 1 by e raised to 1 by h plus 1 minus b cube. This and this term gets cancelled. This is equal to, what is the value of e raised to 1 by h? E raised to 1 by h is equal to e raised to 1 by 0 is equal to e raised to infinity, that is equal to infinity. Now this is equal to 1 plus a cube by infinity plus 8 divided by 1 by infinity plus 1 minus b cube, that is equal to 2. This term is equal to 0 and this term is equal to 0. This implies 8 by 1 minus b cube is equal to 2, or 1 minus b cube is equal to 4, or b cube is equal to minus 3, implies b is equal to minus 3 raised to 1 by 3. A equal to 1 and b is equal to minus 3 raised to 1 by 3. Limit x tends to 2 minus greatest integer function of 2 minus x plus greatest integer of x minus 2 minus x is equal to question. So we have to find left hand limit, LHL. For that, f of 2 minus, that is equal to limit h tends to 0, f of 2 minus h. Replace x by 2 minus h. So this become, LHL become limit h tends to 0, greatest integer function 2 minus x is replacing by 2 minus h, plus x is replacing by again 2 minus h, minus 2 minus x is replacing by 2 minus h, 2 minus h. Okay, this is equal to limit h tends to 0 of greatest integer 2 minus 2, that is equal to minus 2, 2 and this is cancelled, this is equal to greatest integer function of h, plus greatest integer, this is cancelled, minus h, minus 2 plus h. Right. Now what's the value of box h and box of minus h? That is equal to, we know that. I'm going, okay. This is a graph of greatest integer function. 4, 1, 2, minus 1, minus 2. Graph of greatest integer function x. This is equal to 1 to 0, 0 to 1. Then 1 to 2. Then 2 to 3. 1, 2. Minus 1, minus 2. This is equal to open bar. So value of this function, greatest integer function, is equal to 0, this is equal to 0 less than or equal to x less than 1. Box x is equal to 0. For 1 less than or equal to x less than 2. 0, 1 less than x less than or 1 less than or equal to x less than 2. That is open. 2 is not, this is not included. That is equal to box x is equal to 1. And for minus 1 less than or equal to x less than 0. Minus 1 less than or equal to x. So in this region, 0 is not included. This box x is equal to minus 1. Now h tends to 0. So what is the value of this? So that is h is greater than 0 and close to 0. This is the point, very close to 0. But h is a positive quantity. So let h is equal to 0.0001. So box h is equal to box 0.0001. This portion, that is equal to 0. And for box of minus h, that is equal to minus 0.0001. Coming to the left of 0, the value is equal to minus 1, left of 0. So in this region, the value is minus 1. This is equal to minus 1. So the value of this function, box h is equal to 0 plus minus 1 minus 2 plus h is equal to 0. That is equal to minus 3. Limit x tends to 0, greatest integer function of cos x, and limit x tends to 0, greatest integer function of sin x. Okay. Now consider this question. Let's draw the graph of cos x. The graph of cos x is like this, 0. So left hand limit x tends to 0 minus box of cos x, greatest integer function cos. So 0 minus is a point here. So value of the function is slightly less than 1. Value of the function is less than 1 for 0 minus, close to this point. Slightly less than 1 but greater than 0. the value of cos x for x tends to 0 minus the cos x value of cos x is less than 1. That is 0 less than cos x less than 1. So this become so limit x tends to 0 minus and cos x is equal to 0. Now a right hand limit, that is limit x tends to 0 plus box of cos x. For 0 plus, at x is equal to 0, the value of cos x is 1. 0 plus means right to 0, very close to 0. So the value is less for x is equal to 0 plus cos x less than 1. Therefore, limit x tends to 0 plus cos x is equal to 0. Therefore, LHL is equal to RHL is equal to 0. Therefore, limit x tends to 0, greatest integer function of cos x is equal to 0. This is a result. Remember. Now for this question, let's draw the graph of sin x. Graph of sin x. Okay. For this is 0, sin 0 is equal to 0. For x greater than 0 or x is equal to 0 plus a point from the right side of 0 and close to 0, this is 0 plus. The value is greater than 0, sin x greater than 0 but less than 1. So box sin x limit x tends to 0 plus is equal to 0. Now for left hand limit, left hand limit x tends to 0 minus greatest integer function of sin x. Sin 0 is equal to 0. This is a 0 minus is a point approaching from left, that is less than 0. For these values, the value of sin x is less than 0. For x is equal to 0 minus sin x is less than 0. And for minus 1 less than x less than 0. Box of sin x is equal to minus 1. This is our left hand limit. Since LHL not equal to RHL, therefore limit does not exist. So for box sin, for this value, this is equal to 0 and limit exists. Limit exists. For this value, this is LHL is equal to minus 1 and RHL is equal to 0. LHL not equal to RHL. So limit does not exist. Limit x tends to 0, sin of greatest integer of cos x by 1 plus greatest integer function of cos x is equal to question. And we have the result. X tends to 0, greatest integer function of cos x is equal to 0. Okay. Now, taking the limit inside the function, taking the limit inside the function. So this becomes sine of limit x tends to 0, greatest integer function of cos x, by 1 plus limit x tends to 0, greatest integer function of cos x. And value of this function, this is equal to 0. That implies sine 0 by 1 plus 0. Sine 0 is equal to 0 by 1 plus 0. That is equal to 0.